So this is a classic problem in geometry, often referred to as a British flag theorem. The reason is because of the similarities to the British flag. And the way it works, I'm first going to show you how to do it. It's a very simple problem if you know the formula. BP is 4, AP is 8, DP is 7, and your goal is to find this. And so the theorem is, if you have a point anywhere inside a rectangle, the distance to the vertices has the relationship that the square of the opposite sides added together, or opposite segments added together, are the same. So for example, a squared plus c squared equals b squared plus d squared. So in this case, it's going to be 4 squared plus 7 squared equals 8 squared plus x squared. So that's going to get us 1 equals x squared. So x equals 1. So it's a very simple theorem if you know it. If you don't know it, the proof of it's actually quite easy. The way that you do it is you start drawing the distances to that point from the side lengths rather than from the vertices. And so if we let this be x, and then this be y, and then this be z, and this be w, you can start going through and seeing that, for example, we would have x squared plus z squared equals a squared. And then you'd have y squared plus z squared equals b squared. And then you also would have w squared plus y squared equals d squared. And then finally, you would have x squared plus w squared equals, that was a d squared. And so this one's c squared equals d squared. And from these, you can start to recognize. So for example, if I add a squared and c squared together, I end up with x squared plus z squared plus w squared plus y squared. And if I add these two together, I get x squared plus w squared plus y squared plus z squared. And so it's really easy to show that a squared plus c squared equals b squared plus d squared. This is a really nice theorem. Taught a camp today, and no one in the camp, even with some of the best students in the state, didn't know it. And so I thought it'd be a good one to make a video of.